What if we find exoplanets so perfect that they rival Earth itself? Imagine a future moment, perhaps a decade from now, perhaps tomorrow, when the combined lenses of humanity's greatest telescopes lock onto a speck of light circling an ordinary star. At first, it appears as just another data point among trillions, a faint dip in starlight easily lost inside the cosmic ocean. But then the numbers sharpen, the graphs stabilize. The atmosphere readings resolve into something almost impossible. Oxygen signatures layered with water vapor, a hint of methane, and the telltale spectral edges of cloud systems drifting across a surface that reflects starlight with an eerily Earth-like glow. Scientists stare at their monitors in stunned silence as one realization dawns. The planet they are seeing is not merely habitable, it may be perfect, a near twin to Earth itself, orbiting in just the right place, circling a star that behaves just as gently as our own. And for the first time in human history, the idea that Earth is unique begins to loosen its grip on our collective imagination. But what does it actually mean for a planet to be so perfect that it could rival Earth? For centuries, Earth has been our benchmark for habitability, the gold standard against which every other world is compared. Yet, as our instruments advance and our catalogue of exoplanets grows into the thousands, we begin to suspect that Earth might not be a cosmic miracle after all. Perhaps planets like ours are not rare exceptions, but recurring patterns in the grand design of the universe. And if so, what would it feel like to find a world so astonishingly Earth-like that humanity collectively gasps at the sight of it? To understand this possibility, we must first confront the silent assumptions we carry. Most people assume Earth is the perfect home for life, but Earth is far from perfect. Our climate has swung violently throughout its history. Deserts cover a third of our continents. Our magnetic field fluctuates, our atmosphere changes, and our planet is constantly bombarded by cosmic debris. Earth supports life, yes, but it is not optimized for it. A truly perfect planet, one that rivals or surpasses Earth, might have more stable climates, fewer cataclysms, richer ecosystems, or oceans that remain liquid for eons longer than ours. Such a world might be a sanctuary where evolution dances unbroken for billions of uninterrupted years. And if such planets exist, the universe likely hosts civilizations older, wiser, and more complex than anything we have imagined. The journey toward discovering such worlds begins with understanding the narrow band of conditions that allow life to flourish. Astronomers call it the habitable zone, the delicate orbital range where temperatures hover between freezing and boiling, allowing water to remain liquid. But the habitable zone is only the first piece of a deeper cosmic puzzle. To be Earth-like, a planet must orbit a star that burns steadily, without violent flares that could incinerate atmospheres. It must have a magnetic field strong enough to shield life from deadly radiation. It must possess plate tectonics to recycle nutrients, continents to shape weather systems, and oceans that stabilize global temperatures. When all these ingredients combine in harmony, a planet becomes not just habitable, but alive. Now imagine finding not one, but several worlds where these conditions converge with uncanny precision. Worlds where the starlight matches our sun's warmth, where atmospheres breathe with familiar gases, where winds shape coastlines just as they do here. Worlds where forests may already whisper beneath alien skies, or where oceans shimmer with life that never evolved on Earth. What would this discovery mean for humanity? And what would it mean for our understanding of our own place in the universe? The story of such a world would start with light, faint, fragile, and ancient. Telescopes like the James Webb Space Telescope and its successors gather this light grain by grain, photon by photon, decoding colors so subtle that a human eye could never perceive them. As the planet passes in front of its star, the star's light filters through the planet's atmosphere, imprinting chemical signatures in the spectrum. These signatures reveal temperature, cloud structure, atmospheric thickness, and the presence of molecules like oxygen or methane. And when those readings align in a pattern reminiscent of Earth's biosignature, the pattern produced only when life interacts with air, scientists know they have found something extraordinary. But the perfection of such a world would not be defined by chemistry alone. Imagine a world with slightly more water than Earth, giving rise to lush, sprawling coastlines. Or a world with fewer deserts, where rainfall cycles are gentler and climates more forgiving. Imagine continents arranged in ways that prevent supercontinents from forming, reducing long spans of environmental stagnation. Imagine a planet with a more stable axial tilt, avoiding ice ages that reset ecosystems. Evolution could flourish there with fewer interruptions, fewer mass extinctions, more opportunities for complexity to unfold. One cannot help but envision the skies of such a planet. Perhaps the star it orbits is slightly smaller than our Sun, a quiet K-type star, stable for tens of billions of years. Its light would bathe the world in a soft golden-orange hue, gentle yet warm. Evenings might glow brighter, sunsets might last longer. The atmosphere might scatter sunlight into shades Earth has never seen. Copper, peach, violet blue. Clouds might stretch farther, forming towering shapes sculpted by atmospheric pressures just slightly different from our own. To walk on such a world would be to step into a dreamscape, eerily familiar, yet achingly alien. Finding such a planet would overturn our understanding of cosmic rarity. For generations, humanity assumed Earth was a statistical fluke. But what if Earth is simply one of many? What if planets like ours are as common as wildflowers in a meadow? The psychological impact of this revelation cannot be overstated. It reshapes religion, science, philosophy, and our sense of identity. It forces us to imagine civilizations that might have risen and fallen long before Earth formed. And it challenges us to reconsider whether humanity is an evolutionary endpoint or merely a participant in a vast galactic chorus. Yet perfection carries a paradox. A perfect Earth-like world might not merely rival Earth, it might tempt us. Because if such a planet exists, humanity will inevitably ask, could we go there? Could we ever reach it, touch its soil, breathe its air, or watch its oceans shimmer beneath alien moons? The discovery of a perfect world would ignite debates about interstellar travel, ethical exploration, planetary protection, and the future of our species. It would push governments to invest in propulsion technologies that could shrink light years into decades. It would inspire generations of explorers to dream of standing under a sky with two suns or seeing constellations Earth has never known. But before we imagine the journey, we must imagine the discovery. Picture scientists gathered in a control room as atmospheric data from a distant world scrolls across their screens. Oxygen levels stable, methane fluctuations cyclic, water vapor concentration ideal, no signs of excessive radiation. Surface temperature ranging between 50 degrees and 75 degrees Fahrenheit across most latitudes. Ocean coverage at 65%. Magnetic field strength double that of Earth. A world not merely habitable, but thriving. The whispers begin. This is it. We found one. A second Earth. The media erupts. Headlines flash across the globe. Billions of people watch animations of the new world as artists attempt to depict its alien landscapes. Students stare at posters of it pinned on classroom walls. Scientists publish hundreds of papers as they attempt to decode every spectral clue, and humanity collectively imagines the life that may already exist there. But the greatest shock would come when we compare this new world to Earth and realize that in several ways it is better, its atmosphere more stable, its star longer lived, its geological cycles more consistent, its oceans more evenly distributed, its ecosystem potential more vast. If life arose there, it may have persisted for billions of years longer than on Earth. Intelligent species may have emerged, civilizations may have blossomed, perhaps great structures once dotted its continents, now gone. Or perhaps a thriving alien intelligence watches the sky, wondering if they too are alone. The discovery of such worlds leads us to a profound question. If the universe contains planets that rival Earth, why haven't we encountered their inhabitants? This question, a variation of the Fermi paradox, grows sharper with the realization that perfect Earth analogues may be common. Perhaps civilizations rise and fall too quickly. Perhaps they avoid broadcasting their presence. Perhaps they are listening but have not yet heard us. Or perhaps they have already found us and chosen to remain silent. Yet these uncertainties only deepen the allure of a perfect Earth-like world. Because whether life exists there or not, such a planet becomes a mirror, reflecting our hopes, fears, and potential futures. It forces us to examine the fragility of our own world, to appreciate the delicate balances that sustain us, and to imagine how we might improve not just Earth, but every world we one day touch. And so the search continues, driven by a simple, breathtaking question. What if Earth is not the pinnacle of possibility, but merely a beginning? What if somewhere out there, orbiting a star we have yet to study, a world waits, so beautiful, so balanced, so perfect, that it changes not just our understanding of the cosmos, but the destiny of our species? The search for exoplanets that rival Earth, that echo its climate, mimic its atmosphere, and potentially exceed its stability, pushes us deeper into the cosmic unknown. With every new discovery, we update our vision of what a perfect world might look like. Yet perfection is not simply a matter of matching Earth parameter by parameter. Instead, it emerges from a delicate interplay of conditions, each reinforcing the other, creating a planetary symphony where temperature, atmosphere, water, and starlight blend together into something harmonious. To imagine these worlds fully, we must go beyond mere numbers and envision the environments, the histories, and the destinies such planets might hold. Because perfection, when it comes to planets, is less about similarity and more about balance, an enduring equilibrium capable of sustaining life through eras so vast, our minds can barely comprehend them. Consider a planet orbiting a star slightly smaller and cooler than our Sun, a K-type dwarf, often called a Goldilocks star. Unlike red dwarfs, which flare violently, and unlike massive stars that burn out quickly, these stars offer stability measured not in billions, but in tens of billions of years. Their long, gentle lifespans provide a stage upon which life could flourish without catastrophic interruption. Imagine a world circling such a star, its orbit nearly circular, its seasons mild, its climate unbroken by the extreme shifts that punctuate Earth's deep history. Rain falls in predictable cycles. Monsoons return with reassuring regularity. Storms do not carve continents apart. Such a world might maintain a stable biosphere for time spans that would carry Earth through 5 or 6 entire evolutionary ages. This alone could make it more perfect than Earth, because on such a world, evolution would have time to experiment endlessly. Now picture the planet's atmosphere, a soft blend of nitrogen, oxygen, and trace gases, enriched not by chance, but by the steady respiration of ancient forests, sprawling oceans, and ecosystems adapted over billions of unbroken years. Unlike Earth's atmosphere, which has swung dramatically in composition, from oxygen-free to oxygen-rich, from greenhouse hot to snowball cold, this world's air remains remarkably stable. Volcanoes erupt occasionally, but never with the violence that wiped out species after species on Earth. The magnetic field, stronger than ours, shields the planet from cosmic radiation with unwavering strength. Throughout deep time, the biosphere thrives without facing extinction-level events that reset evolutionary clocks. Life on such a planet could grow older, more complex, and perhaps even more intelligent than life on Earth ever had the chance to become. The landscapes of this world would reflect its stability. Imagine continents shaped not by violent tectonic collisions, but by slow, graceful drift. The mountains are ancient, but not jagged, weathered into soft ranges carpeted by forests whose roots reach down through layers of rich, fertile soil. These forests expand continuously because fires are rare, storms moderate, and climates predictable. Rivers flow with nutrients recycled endlessly from ocean to land and back again. The oceans themselves shimmer with a clarity that hints at stable chemistry. No great die-offs, no sudden toxic blooms. Coral-like organisms might flourish across entire coasts, constructing underwater metropolises of intricate beauty. The seas teem with life, from microscopic organisms to large, complex creatures that glide through currents shaped by gentle differences in temperature. On such a world, weather becomes a kind of planetary heartbeat, steady, rhythmic, nourishing. Clouds drift above landscapes that have changed little over millions of years, each region receiving exactly the balance of sunlight, rainfall, and seasonal variation needed to support vibrant life. The planet may even possess more than one moon, allowing tides to flow in patterns more complex than Earth's, giving rise to coastal ecosystems of staggering diversity. A perfect world would likely have a tilt that varies little, preventing ice ages and global freezes. Snow might fall only in the highest elevations, and deserts may be almost non-existent, replaced by savannas, wetlands, and fertile plains that stretch for hundreds of miles. But what makes this imagined world so compelling is not only that it could support life, it is that life would thrive endlessly. Where Earth faced 5 known mass extinctions, this world might have seen none. Evolution would be a continuous ascent, not a staircase interrupted by disaster. If intelligent life arose there, it might have developed technology millions of years ago, growing into a civilization more advanced than ours by orders of magnitude. Or perhaps intelligence never formed, but life took other paths, producing organisms more spectacular, more bizarre, and more beautiful than anything we can conceive. Yet perfection does not guarantee familiarity. A planet that rivals Earth may still surprise us in ways that expand our imagination. Perhaps the dominant life forms are not land-based, but oceanic. Imagine vast networks of floating organisms, some as large as islands, feeding on nutrients drawn from deep currents. Others might produce bioluminescent displays across the water's surface, glowing in iridescent blues and greens that pulse with the turning of tides. Maybe forests grow taller and denser than Earth's, their canopies spiraling upward under the influence of slightly higher atmospheric pressure. Leaves could shimmer with metallic colors, optimized to absorb the orange-tinged light of a K-type star. Flowers might bloom in shapes and patterns beyond Earth's biological palette. The sheer abundance of niches in such a stable environment would generate evolutionary creativity we can hardly predict. But what if the perfection we find goes beyond habitability and aesthetics? What if we discover a world whose environment actively encourages the emergence of intelligence? On Earth, intelligence is a rare trait developed by only a handful of species. But on a planet with stability extending through epochs longer than the age of all mammalian evolution, intelligence might arise repeatedly. Different species, in different environments, could evolve sophisticated problem-solving abilities, communication languages, social structures, or even technology. Some may dominate, others may coexist, and still others may retreat to isolated ecosystems. A perfect Earth-like world might not host a single intelligent species. It might host many. Its biosphere could resemble a vast, interconnected network of consciousness, each species contributing its own perspective to the planetary experience. Imagine a civilization not driven by survival crises, no ice ages to flee, no supervolcanoes to endure, no asteroid impacts threatening extinction. A society emerging on such a world would grow within an environment of abundance. Without the constant threat of destruction, their technological path might differ drastically from ours. Instead of focusing on warfare or survival engineering, their innovations might revolve around biology, art, philosophy, or exploration. Their societies could flourish for tens of thousands of years without interruption, leading to levels of advancement unimaginable to us. And if they ever looked outward to the stars, spotting Earth, they might see our world as rough, chaotic, and fragile compared to their own. Yet this raises a profound question. If such perfect worlds exist, why have we not yet detected signs of their civilizations? One possibility is that they have no need for detectable technology. A civilization in perfect harmony with its world may never industrialize, may never broadcast, may never build megastructures. Their presence would be invisible to our telescopes, hidden behind the silence of a biosphere that thrives without machines. Another possibility is that intelligent life does not inevitably lead to technological life. Perhaps intelligence expresses itself through biology, not engineering. Perhaps the greatest minds of such a world are organisms that perceive the environment in ways we cannot imagine, beings whose thoughts ripple through networks of roots, waves, or chemical signals rather than circuits and metal. But perhaps the most humbling possibility is that these civilizations were once vibrant, but are now gone. A world can be perfect for billions of years, but nothing lasts forever. Stars evolve, climates shift, continents drift. Perhaps the inhabitants once flourished, built wonders, explored their oceans, mapped their skies, and then, slowly, gently, their civilization faded as environmental changes demanded adaptation they could not sustain. Their ruins, if they exist, may now lie hidden beneath forests or oceans, reclaimed by the biosphere that nurtured them. If we ever visit such a world, we might find traces of lost civilizations, artifacts encrusted in coral, ancient cities turned to dust, or symbols carved into stone eroded by time. Yet even without civilizations, the discovery of such a world would transform humanity's future, because a perfect Earth-like planet is not just scientifically astonishing, it is a destination, it is a promise, it is a place where our species might someday take root. We would imagine future generations building cities beneath alien skies, studying ecosystems teeming with unfamiliar life, and learning to coexist with a biosphere shaped by billions of years of undisturbed evolution. It is not merely a second Earth, it is a new chapter for humanity, a world that invites us not only to explore, but to evolve. Such a discovery would reshape our motivations as a species. Governments would invest heavily in propulsion technologies capable of reaching distant stars. Space agencies would draft plans for interstellar probes, robotic explorers, and eventual crewed missions. Humanity's timeline would stretch beyond Earth, beyond the solar system, beyond the present. Science would accelerate, culture would shift. The stars would no longer be distant dreams. They would be destinations, goals, futures waiting to be realized. But before any journey begins, the first step is recognition, the moment when we see the spectral signature of a world that rivals Earth and understand what it means. It is the moment when our cosmic isolation cracks, when the universe reveals that Earth is not alone, not exceptional, not singular. And in that revelation lies hope. Hope that life is abundant, that worlds flourish everywhere, and that humanity's next great adventure awaits just beyond the reach of our current technology. A perfect world does not diminish Earth, it elevates it, by showing us that life can thrive not just here but across the cosmos. Such a world becomes a beacon guiding us forward. It inspires us to protect our planet, to cherish its fragile balances, and to become worthy explorers of the galaxy. Because if perfect worlds exist, then our destiny is far larger than we ever imagined. The possibility of discovering a world that rivals, or even surpasses, Earth in its capacity to nurture life, forces us to question everything we assume about planetary perfection. Until recently, we believed Earth was the rare exception, a cosmic stroke of luck produced by an improbable alignment of circumstances. But as our telescopes sharpen and our catalogues expand, a new picture begins to emerge, one where Earth-like worlds may be common, and worlds better than Earth may quietly orbit stars scattered across the Milky Way. This shift in perspective leads us into a deeper exploration, not just of planets themselves, but of what optimal habitability truly means. Because perfection, in this cosmic sense, is far more nuanced than simply checking the familiar boxes of atmosphere, oceans, and sunshine. It encompasses the evolution of climates, the histories of ecosystems, the rhythms of geology, and the interplay between life and environment over eons. To understand these worlds more fully, imagine first the concept of a planet that is not merely stable, but self-correcting. Earth teeters on the edge of chaos, its climate regulated only loosely by feedback loops that sometimes succeed and sometimes fail. Ice ages sweep across continents, supervolcanoes erupt and blanket skies in ash. Ocean currents shift, biodiversity plummets and then slowly recovers. But a perfect world, one that rivals Earth in every respect, would possess mechanisms more finely tuned. Perhaps its atmosphere contains a slightly higher concentration of gases that naturally maintain stable temperatures. Perhaps its oceans circulate heat more efficiently, preventing the extremes that periodically challenge Earth. Perhaps its continents are spaced in such a way that no region becomes too cold, too hot, too arid, or too volatile. These subtle differences could create an environment in which life not only survives, but thrives without interruption. Consider geology, the silent architect of planetary habitability. On Earth, plate tectonics recycle carbon, build mountains, and shape continents, but they also trigger earthquakes, volcanoes, and mass destruction. What if a perfect world has gentler tectonics? Imagine plates that move slowly and steadily, releasing nutrients without catastrophic eruptions. Imagine volcanoes that enrich the atmosphere with life-supporting gases without producing planet-killing explosions. Such a world would enjoy a consistent supply of essential elements, feeding ecosystems without disrupting them. Geological calm might stretch across billions of years, allowing biodiversity to flourish with fewer existential threats. Now imagine the atmosphere, our planet's invisible skin, fragile, yet essential. Earth's atmosphere is a product of chance, early volcanic outgassing, the emergence of photosynthetic life, the slow accumulation of oxygen. But it is imperfect. Too little oxygen for half its history, too much carbon dioxide during greenhouse episodes, too thin during cold periods. A truly optimal atmosphere might maintain a near-perfect balance between greenhouse warming and cooling mechanisms. It might possess a chemical composition that filters harmful radiation more efficiently, protecting life on the surface without requiring creatures to develop specialized defenses. Perhaps it contains trace gases unknown to Earth that stabilize climate or reinforce protective layers in the upper atmosphere. On such a world, the sky may appear clearer, the air denser, the clouds more structured, each contributing to an environment where evolution happens not in fits and starts, but with smooth continuity. The oceans of a perfect world would be just as vital and potentially quite different from Earth's. Earth's oceans are dynamic, beautiful, and essential to life, but they also suffer from stagnation events, circulation shifts, and periods of anoxia that devastate marine ecosystems. On a more stable world, ocean currents might run deeper and more consistently, bringing nutrients from the abyss to the surface in predictable cycles. The waters could remain oxygen-rich throughout their depths, supporting complex life forms far below their sunlit zones. Coral-like organisms might form colossal structures that rival Earth's reefs, stretching for hundreds of miles and housing millions of species. Marine life could evolve in branches of complexity that Earth never had the opportunity to explore, including intelligent species adapted to deep-sea environments where pressure and darkness create evolutionary challenges unlike anything on land. Now shift your focus to the sky, the dome of light that shapes every organism's daily existence. The quality of starlight profoundly influences a planet's climate and biology. Earth orbits a relatively stable star, but even the sun has its temperamental moments. What if the star of our perfect world shines with even greater consistency? A K-type star, smaller and cooler than our sun, would emit light in a slightly warmer color palette. Soft golds, deep ambers, muted reds. Plants evolving under such light might develop pigments that reflect shimmering copper or violet hues. Photosynthesis might be more efficient, giving rise to forests thicker than any on Earth, stretching unbroken across continents. Animals might evolve sensory systems tuned to the warm spectrum of starlight, perceiving colors we cannot see and interacting with their world in ways we can scarcely imagine. But perfection is not just physical, it is also temporal. Time shapes habitability as much as climate does. Earth has had life for 8 billion years, but complex life only for a fraction of that time. Mass extinctions reshaped evolution repeatedly, wiping out progress and forcing nature to begin again. A perfect world might experience few or none of these resets. Without catastrophic interruptions, evolution could climb steadily toward increasing complexity. Intelligent life might arise sooner, or in multiple lineages simultaneously. Civilizations could stretch across hundreds of millennia without collapse. Cultures, technologies, philosophies, and sciences could develop with a richness our fragmented history does not allow. Imagine arriving on such a world, whether through telescopic observations or by interstellar travel, and discovering evidence of ancient civilizations, long vanished but not entirely erased. Perhaps enormous structures lie hidden beneath forest canopies, overtaken by vegetation after millions of years. Perhaps intricate carvings mark cliff faces, eroded but still decipherable. Perhaps fragments of crystalline tools or metallic alloys rest in sediments, waiting to be uncovered. Such relics would reveal not only the planet's past, but the depth of time across which life evolves. They would remind us that civilizations may rise and fall repeatedly on worlds where stability reigns, each new society building upon the remnants of the one that came before. Yet perfection can carry surprises, qualities that challenge human expectations. For example, a perfect Earth-like planet might have higher gravity than Earth. If the planet is slightly larger, its gravity could make movement more difficult, but it would also enhance atmospheric retention and potentially allow for richer ecosystems. Plants might grow shorter but denser. Animals might evolve powerful musculature or develop unique locomotion methods, such as gliding or springing using tendon-like structures. Flying creatures might be rare or uniquely adapted. Rivers might carve deeper channels. Mountain ranges might rise more slowly, but appear more massive. Every aspect of life would adapt to this fundamental physical difference, creating a biosphere subtly but profoundly distinct from Earth's. Or consider the possibility of additional moons. Earth's single moon stabilizes our axial tilt, moderates tides, and influences many biological rhythms. What if a perfect world has 2 or 3 moons? Their combined gravitational influence could create tide systems of extraordinary complexity, generating ecosystems that shift and pulse with a rhythmic harmony unknown to Earth. Coastal life might synchronize with multi-moon cycles, producing migrations, spawning patterns, and evolutionary behaviors shaped not by a single lunar phase, but by a celestial dance of shifting gravitational tides. The magnetic field of such a world might be stronger than Earth's, shielding the surface from cosmic rays and solar wind with unmatched effectiveness. This could allow life to flourish closer to the poles, making them lush instead of icy, vibrant instead of barren. Imagine forests stretching into regions that, on Earth, would be tundra. Imagine animals adapted to year-round twilight under shimmering auroras amplified by powerful magnetospheric interactions. Yet the most startling feature of a perfect Earth-like world might be its biosignature, the chemical fingerprint of its living systems. If we detected an atmosphere with oxygen levels slightly higher than Earth's, methane produced at steady rates, and gases like isoprene or dimethyl sulfide in concentrations hinting at widespread biological activity, scientists would immediately recognize something extraordinary. These signals would suggest not only the presence of life, but the presence of abundant, thriving ecological networks. To find such signatures would be akin to hearing the faint echo of a distant symphony, one played on a world that may have nurtured life for billions of years longer than Earth has existed. This leads us to a profound realization. The universe may not simply contain planets that can support life. It may contain planets that have optimized themselves for it. Worlds where life is not a fragile phenomenon, but a foundational force shaping every aspect of the planet's character. Worlds that rival Earth, not because they copy its design, but because they refine it. The discovery of such worlds would reshape our scientific priorities. Astronomers would focus their instruments on the smallest spectral variations, searching for atmospheric patterns even more indicative of life than those on Earth. Exobiologists would begin drafting models of evolutionary pathways that assume not Earth-like scarcity, but Earth-surpassing abundance. Philosophers would question whether humanity's turbulent developmental history is typical, or whether other intelligent species evolved under far more forgiving circumstances. And through all of this, one question would loom. If perfect worlds exist, will humanity ever reach them? If they lie hundreds or thousands of light years away, we must either invent propulsion systems beyond anything we currently possess, or accept that generations of humans may be born, live, and die aboard starships bound for these distant paradises. But if such worlds are closer, within 20 or 30 light years, they become not dreams, but futures, destinations, opportunities for humanity to become, at last, a multi-planetary, then multi-stellar species. Because a perfect world is more than a scientific discovery. It is a promise that Earth is not the limit of what life can achieve. It is a reminder that the universe abounds with potential, and that humanity's greatest stories have yet to be written. If the universe truly contains planets that rival Earth in beauty, stability, and biological potential, then our journey now leads us to one of the most profound implications of such discoveries: how these worlds reshape our understanding of time, evolution, culture, and the future of humanity. Because, as amazing as a perfect planet like Earth might be physically, with balanced climates, vast oceans, stable stars, and thriving ecosystems, there is another dimension of perfection that is perhaps even more transformative: the temporal dimension. A world's history, its age, its evolutionary timeline, and the duration of its habitability can mean the difference between arid beauty and cosmic splendor. And if we find a planet that not only resembles Earth, but also sustains life for far longer than Earth ever could, then we are not merely discovering a world, we are finding a reflection of what life can become when it receives time itself as a gift. Imagine a planet billions of years older than Earth, orbiting a star that remains stable for tens of billions of years more. Such a world would have passed through its violent youth long before Earth finished forming. It may have been calm, wet, and rich with nutrients while our planet was still molten. Life could have emerged there while Earth's oceans were just beginning to condense from volcanic steam. That means evolution on this perfect planet could have a head start of hundreds of millions, or even billions, of years. Its ecosystems could be unimaginably complex. Its biodiversity could dwarf that of Earth. Its biosphere could be a masterpiece sculpted by time, uninterrupted by mass extinctions, asteroid strikes, or catastrophic climate swings. On such a world, jungles might teem with ancient lineages of organisms that have perfected their physiology over spans so vast that Earth's entire evolutionary history looks brief in comparison. Perhaps there are creatures with sensory modalities beyond anything we can conceive, organisms that detect magnetic fields with crystalline organ systems, or beings that communicate through bioelectric pulses, or species that evolved neural architectures far more efficient than Earth's tangled synapses. The air itself might hum with chemical conversations among intelligent flora, each participating in a biosphere more interconnected than any ecosystem Earth has ever known. Yet the greatest shock may lie beneath the soil. Sediment layers might reveal fossils stretching back 6 or 7 billion years, fossils from eras so ancient that they predate the sun itself. Imagine digging through layers of geological time deeper than the history of our solar system, finding remnants of organisms that lived and died long before Earth's first microbial mats arose. The very existence of such records would challenge our theories about abiogenesis, evolution, and the conditions required for life's emergence. It would suggest that life is not fragile or rare, but robust and cosmically eager, a process that unfolds wherever chemistry finds stability. But not all perfect planets need be ancient. Some may be younger than Earth, yet still exhibit extraordinary harmony. Imagine a newly formed world orbiting a quiet star, rich in carbon, water, and organic molecules. Its youth might give rise to ecosystems with rapid evolutionary turnover, producing novel life forms at speeds unimaginable on Earth. Evolution might be turbocharged by high mutation rates balanced by gentle environmental conditions. Species might diversify explosively, filling ecological niches with creativity shaped not by harsh competition, but by abundant resources. In such a world, harmony does not arise from age, it arises from opportunity. This leads us to the cultural implications of perfect Earth-like planets. Suppose humanity detects not just life, but signs of intelligence, not radio signals or megastructures. Those remain speculative and difficult to detect, but subtle atmospheric signatures of advanced biological activity. For example, unusual industrial byproducts in the air, stable chemical gradients maintained only by ecological engineering, or seasonal atmospheric fluctuations too precise to be natural. These would hint at a civilization that exists, but does not broadcast itself. A civilization perhaps technologically advanced, perhaps reclusive, perhaps uninterested in communication. Their silence would raise profound questions. Are they hiding? Are they cautious? Are they peaceful? Or are they simply not concerned with forms of communication that matter to us? Imagine a world where intelligence evolved not from competition, but from collaboration, where social structures are built not upon dominance hierarchies, but upon networks of shared cognition. Perhaps the dominant intelligent species is not a bipedal organism, but a distributed superorganism, an interconnected biological network that spans forests or oceans. Their thoughts might flow through living fiber-like tissues, generating collective decisions. Their concept of individuality might be non-existent. Their idea of technology might involve manipulating ecosystems rather than constructing machines. To encounter such a world would not simply expand our understanding of life, it would redefine consciousness itself. But perhaps the perfect Earth-like planet harbors no intelligence at all. Perhaps its perfection lies in its untouched purity, a world where evolution progressed, but never toward tool use, where creatures roam free in ecosystems that operate with precision, where predation, symbiosis, reproduction, and adaptation have achieved a delicate dance that remains balanced without external influence. To explore such a planet would be to witness nature's full potential, raw, complex, and unaltered by civilization. and such a discovery would raise an ethical dilemma. Do we have the right to disturb it? Humanity's tendency to reshape environments is undeniable. If we find a perfect world, the temptation to colonize it may be overwhelming. But colonization brings risk, not only to the planet's life, but to ours. Unknown viruses, unfamiliar chemical cycles, or incompatible ecosystems could threaten human settlers. Conversely, human microbes could wreak havoc on a planet whose biosphere evolved without them. Planetary protection protocols would become more than academic. They would become moral imperatives. The question, should we, would matter as much as could we? Yet even if we never set foot on such worlds, their discovery would change us. Humanity has long believed itself exceptional. Earth was our cradle, our classroom, our proving ground. The idea that other planets might rival Earth challenges our uniqueness. It forces us to confront the possibility that life and intelligence might be universal outcomes of planetary evolution. And if life is widespread, then humanity becomes not a cosmic anomaly, but a cosmic participant. Our sense of purpose shifts, our ambitions grow, our fears evolve. Consider how society would react. Religions might reinterpret their teachings to incorporate the existence of other inhabited worlds. Philosophers might debate whether morality is universal or planet-specific. Governments might struggle with the implications of interstellar exploration. Space agencies might experience explosions of funding and interest as people demand to see these worlds for themselves. The arts would flourish with visions of alien landscapes, alien ecologies, and alien ways of thinking. But perhaps the most profound impact would be on our relationship with Earth. For the first time, humanity would see our home not as the one and only oasis in a barren universe, but as one exquisite example among many. We would begin to see Earth as a gift, not a guarantee, as something worth protecting with the greatest vigilance. Because a universe filled with perfect planets reminds us that perfection is not a miracle, it is a responsibility. Think of humanity's future in this expanded cosmic context. If perfect worlds exist, they offer not only scientific wonder, but opportunity. They could become destinations for future explorers, refugees for future civilizations, or even catalysts for new eras of human development. Imagine starships powered by fusion or antimatter engines, crossing interstellar space to reach a world where humanity could build cities under alien suns. Imagine children born beneath skies filled with unfamiliar constellations, growing up knowing their world has sisters scattered across the galaxy. Imagine humanity evolving into a multi-world species, a civilization no longer tied to a single point of vulnerability. But the journey towards such futures begins with a single discovery. The moment we confirm that Earth has rivals among the stars, that somewhere out there, a planet orbits quietly, waiting, a planet where life may already be thriving, a planet that proves we are not alone, not biologically, not cosmically, not existentially. And in that moment, humanity will experience a shift unlike anything in its history, a shift not just of science, but of identity. Because the discovery of perfect Earth-like worlds is more than a scientific milestone. It is a transformation of the collective human soul. It is a reminder that the universe is not indifferent chaos, but a place rich with possibility, a place where life can emerge, grow, flourish, and perhaps even communicate across the void. And if all of this is true, if perfect worlds await us, then everything we know about life, intelligence, and our place in the cosmos is about to change forever. If perfect planets like Earth exist, worlds so finely balanced, so surprisingly stable, so biologically rich that they defy the very definition of habitability, then let's explore an even deeper and more disturbing question. What if perfection itself produces unexpected consequences? Because a world can be stable, beautiful, and teeming with life, and yet still challenge our assumptions about evolution, technology, and survival. The more perfect a planet is, the stranger its perfections can become. And the stranger the perfection, the greater the impact on humanity when we finally discover such places. Imagine a world where evolution progressed not in fits and starts, shaped by mass extinctions and violent climate turbulence, but on a gentle, uninterrupted slope of complexity. A world where catastrophic asteroid strikes never occurred, where volcanic upheavals remained mild, where climate cycles remained stable for billions of years. Such a planet might produce ecosystems that are unimaginably intricate. Species could develop in long evolutionary arcs that refine traits until they reach nearly optimal efficiency. Predator-prey dynamics might stabilize instead of escalating into evolutionary arms races, creating ecosystems that resemble choreographed ballets rather than chaotic contests for survival. Yet this raises a profound possibility. What if such a world evolves intelligence far later than Earth, or not at all? Because catastrophes, those destructive forces we fear on Earth, can also act as creative engines, clearing ecological space, allowing new lineages to rise, and accelerating innovation through evolutionary pressure. Without mass extinctions, mammals might never have replaced dinosaurs on Earth. Without ice ages, humans might never have developed our large brains, dexterous hands, and ability to adapt to wildly shifting environments. On a perfectly stable world, evolution might become comfortable, efficient, specialized, but perhaps too specialized. Life might settle into near-perfect ecological loops that leave no room for sudden leaps in cognition. Intelligence may never become advantageous in such a world. Why develop tools if the environment never changes? Why innovate if food is abundant, climates are gentle, and threats are minimal? Natural selection might favor stability over creativity, leading to organisms adapted so precisely to their niches that behavioral flexibility becomes unnecessary. A planet like this could be breathtakingly perfect and yet devoid of any civilization, a biological paradise without minds, a world that thrives without self-awareness. Humanity would see such a place not as a failure, but as a mirror, showing us that intelligence is not the inevitable outcome of evolution, but one of many possible trajectories life can take. It would remind us that intelligence is rare, not because it is superior, but because it is unnecessary on most worlds where stability reigns. But there exists the opposite possibility, that perfection could nurture hyper-intelligence. Imagine a planet where life had billions of additional years to evolve, uninterrupted by catastrophes. A species there might be as far beyond us as we are beyond trilobites. Their neural complexity could surpass anything our biology could feasibly achieve. Perhaps they have solved aging, merging biology with ultra-stable biochemistry. Perhaps they evolved collective consciousness, or a form of communication so subtle and profound that they share thoughts with the precision of mathematics and the expressiveness of art. Their civilization might not build machines or cities. Technological advancement might instead manifest as biological engineering, so seamless that it appears natural. Their architecture might be grown from living tissues rather than constructed from stone or metal. They might not travel to space because they have already reshaped their world into an interconnected living organism. To humans, such a civilization would be both wondrous and incomprehensible. We may struggle to recognize their structures, their communication, or even their existence. But what if they noticed us first? Consider the distance between their biology and ours. If they evolved over billions of years, their concepts of communication, intelligence, morality, and existence might not align with anything we understand. They might refrain from contact not out of hostility, but because they view interference as unethical. Or they might lack any concept of individuality and therefore struggle to comprehend human culture. Their silence would not be a message of isolation, it would be a message of humility. Now imagine a different type of perfection, geophysical perfection, a planet where plate tectonics operate with flawless efficiency, producing fertile soils, stable continents, and predictable volcanic cycles. Without excessive mountain building or crustal instability, sea levels remain steady for eons. Oceans circulate in rhythmic, balanced patterns that distribute nutrients evenly across the globe. On such a world, the biosphere would be fed continuously by deep Earth chemistry, enabling massive marine ecosystems and flourishing coastal environments. Or consider a world with a magnetic field stronger and more stable than Earth's. Such a planet would be shielded from stellar radiation so effectively that atmospheric chemistry remains pristine. Ozone layers would stay robust. Surface life would be protected from cosmic events that periodically threaten ecosystems on Earth. Life on this world might never need to adapt to sudden radiation exposures, allowing evolutionary stability unmatched by anything our planet can offer. But perfection comes with limits. A world too geologically stable might lack the mineral diversity needed for rapid technological development. On Earth, civilization relied heavily on accessible metals, varied deposits of ores, and tectonic movement that exposed new materials. A perfect world might bury its mineral wealth under untouched crustal layers, leaving intelligent species without easy access to metals. Their technology might therefore develop along entirely different pathways, biological, chemical, or cognitive instead of mechanical. Now imagine the climatic perfection of a world with a nearly circular orbit, a stable axis tilt, and a star whose energy output varies by only tiny fractions across billions of years. Without ice ages, superstorms, or sudden shifts in precipitation patterns, ecosystems could flourish with extraordinary consistency. Forests might grow uninterrupted for millions of years. Coral reefs might reach levels of diversity unimaginable on Earth. Species turnover could slow dramatically. The world would be filled with evolutionary lineages that stretch back to epochs so ancient that they feel impossible. Yet such stability would also mean that ecosystems become incredibly sensitive to disruption. A small asteroid strike, a sudden volcanic eruption, or an invasive species introduced by human explorers could collapse ecological networks that took billions of years to assemble. Perfection requires balance, and balance is fragile. This leads to a haunting question. Should humanity ever visit such worlds at all? And an even deeper one, if perfection exists, does humanity have the discipline to preserve it? The discovery of a perfect Earth-like planet would force humanity to confront its legacy. Our planet bears scars from extraction, pollution, and ecological imbalance. To arrive at a world that evolved in harmony, without industrial scars or ecological trauma, would hold a mirror to our own shortcomings. Would we bring our industries there? Would we terraform it to fit our needs? Or would we protect it with reverence, treating it as a galactic sanctuary? But perfection may also apply not to life, climate, or geology, but to opportunity. Imagine a world perfectly positioned for humanity's future expansion, not because it is already habitable, but because it is malleable. A world with the right atmospheric pressure, the right chemical composition, the right temperature range, the right gravity. A blank canvas ready for terraforming. A planet that could become a new Earth, not because nature made it so, but because humanity could. Such a world would change everything about our future. Instead of searching only for planets with existing life, we would begin identifying planets ideal for human life to create. This reframes the search for exoplanets from a biological quest into a civilizational one. The perfect planet may not be the one that resembles Earth today. It may be the one that could become Earth tomorrow. If humanity becomes a multi-planet species, perfect worlds will shape our culture, technology, and identity. Some worlds might become utopias for scientific research. Others might specialize in industry or agriculture. Others might be preserved as nature reserves. Over generations, humanity might diversify into planetary cultures shaped by local conditions. On a high-gravity world, humans might grow shorter and stronger. On a low-gravity world, taller and more delicate. On tidally locked worlds, societies might develop entirely different concepts of time. A universe with perfect worlds is a universe that encourages exploration, diversification, and transformation. Humanity would no longer be one civilization. We would become many. But perhaps the most beautiful idea of all is this: a perfect world does not diminish Earth's value. It enhances it. Earth becomes not a lone miracle, but one jewel among many. Not an exception, but part of a cosmic family. Not an isolated cradle, but the first chapter of a much larger story. And in that realization, humanity gains something priceless, a sense of belonging to the universe itself. If the universe indeed contains planets so perfect that they rival, perhaps even exceed, Earth in balance, beauty, and biological potential, then we must explore a deeper dimension of this cosmic possibility, how perfection itself influences destiny. Because if worlds can be perfect, their perfection will shape not only the life that emerges there, but the civilizations that arise, the technologies they pursue, the challenges they face, and the futures they build. A perfect world is not merely a location. It is an environment that sculpts every aspect of existence across geological and cultural time. And such worlds, if we ever encounter them, will challenge not only our science, but our understanding of destiny, survival, and what it means to flourish. Imagine a planet that maintains equilibrium so stable that its climate changes only gradually across millions of years. On Earth, Evolution is driven by disruption. Ice ages, volcanic winters, asteroid strikes, and shifting seas. These traumatic events create new niches, eliminate stagnant lineages, and push species to develop novel traits. But on a more perfect world, disruption rarely comes. Conditions remain so consistent that complex species may evolve slowly, refining existing adaptations rather than exploring radical new ones. Life would reach a state of equilibrium, an intricate symphony in which every organism plays a role. Forests would develop layered canopies filled with species that co-evolved in harmony. Oceans would hold stable currents and nutrient cycles that support megafauna of breathtaking diversity. Grasslands could stretch for continents, shaped by herbivores that move in patterns older than human civilization. Yet stability creates challenges. Without environmental upheaval, intelligence may arise more slowly. Humans evolved large brains partly because we faced unpredictable conditions. A perfect world may eliminate the evolutionary pressures that reward creativity and problem-solving. Species may become so finely adapted to their niches that their ecological roles never require innovation. If intelligence emerges at all, it might come from entirely different pressures, perhaps through social cooperation, communication complexity, or ecological interdependence. But imagine a world where perfection does not hinder intelligence. It accelerates it. A world where stable climates allow species to experiment with cognition across millions of years. Where a gentle environment provides the safety needed for brains to grow larger, social behaviors to expand, and symbolic thought to emerge. Imagine creatures evolving communication systems rich with nuance long before they discover fire or tools. Intelligence might develop first in oceans, among beings shaped by buoyant water and gentle temperatures. Neural structures could evolve with far greater flexibility, unconstrained by the survival pressures that shaped Earth's creatures. On such a world, civilization might appear in forms humanity struggles to understand. Perhaps intelligent species create technology through biological engineering, growing tools from living tissues instead of forging them from metal. Or perhaps they have no need for external tools at all. Their bodies may incorporate biological mechanisms capable of manipulating the environment at microscopic scales. They may grow shelter, sculpt materials, or control other organisms through symbiotic communication. Their cities could resemble forests, coral structures, or crystalline formations, living environments sustained by biological harmony rather than mechanical infrastructure. Imagine standing on such a world and seeing a civilization that builds with life rather than destroying it. Streets formed from intertwined roots that pulse with nutrients. Homes shaped by engineered trees that respond to weather by shifting their leaves. Transportation systems made of living organisms cooperating in vast symbiotic networks. To human eyes, this might feel fantastical, almost magical, but to them, it would be natural, a logical extension of evolution in a world that nurtures harmony over conflict. Yet perfection may not guarantee peace. A species growing in a stable world may face pressures we do not. Without existential threats, competition for resources could become more subtle and psychological. Cultural conflict might revolve around ideas, philosophies, or interpretations of nature rather than survival. Their histories might be filled not with wars of territory, but wars of meaning, struggles over cosmic purpose, environmental stewardship, or the ethical boundaries of biological manipulation. Or perhaps they avoid conflict entirely. Intelligence may evolve in species that value cooperation above all else, shaped by millions of years of mutualism in ecosystems designed for balance. If their world teaches that survival depends on cooperation rather than competition, their societies might reflect that lesson. Decision-making could be communal, leadership could be emergent, conflicts might be resolved not through domination, but through biological integration, literally merging ideas, memories, or behaviors through biochemical communication. Their consciousness might extend beyond individuals into networks, clusters, or entire ecosystems. But what if perfection shields them too well? A civilization nurtured by stability may become unprepared for rare catastrophes. A stellar flare, an asteroid impact, or even a change in solar luminosity could devastate ecosystems unaccustomed to volatility. Technological advancement might lag compared to Earth's because there is simply less urgency. Why invent spacecraft if the environment is endlessly generous? Why develop advanced medicine if disease rarely threatens? Why explore the stars if their world already provides everything needed for a fulfilling existence? And so we reach a paradox. A perfect world might produce either the most advanced civilizations imaginable, or none at all. This paradox shapes humanity's future as well. When we discover such worlds, we must confront what we hope to find. Are we searching for companions among the stars? Species whose minds echo our own? Or are we seeking untouched beauty? Worlds that remind us of what Earth once was, or what it could become? The answer may lie not in scientific ambition, but in introspection. For if we find perfect worlds, humanity must ask, what is our responsibility to them? Do we observe from afar? Do we visit as explorers? Do we settle them as new homes? Or do we leave them untouched, sacred in their cosmic beauty? The ethical implications are enormous. Colonizing a perfect world risks introducing alien microbes, altering ecosystems, or even destroying species that evolved over billions of years. Even if the world holds no intelligent life, its biological harmony may be fragile. A single bacterium from Earth could disrupt ecological networks shaped across unimaginable stretches of time. Yet we cannot deny the pull such worlds would exert on humanity. The urge to explore, to settle, to expand beyond Earth is woven into our history. Perfect planets, once discovered, would inspire dreams of interstellar migration. They would become symbols of hope, new beginnings, opportunities for humanity to grow, diversify, and transcend the limits of our single world. Imagine future humans walking beneath alien trees, whose leaves shimmer with pigments absorbing wavelengths from a star slightly redder than the sun. Imagine oceans glowing with bioluminescent organisms evolved to communicate across vast distances. Imagine skies filled with constellations unfamiliar to Earth-born eyes. Entire cultures would develop around these landscapes. Stories, myths, art, and science would merge into traditions unique to each planetary home. As generations pass, humans might adapt to local conditions. On high-gravity worlds, humans may grow shorter, with denser bones and more powerful muscles. On low-gravity worlds, humans may grow taller, more slender, and more agile. On worlds with perpetual twilight, we may develop new circadian rhythms. On worlds with stronger magnetic fields, we may evolve heightened sensitivity to electromagnetic phenomena. Humanity's future could splinter into planetary lineages, each adapted to its world. Diverse branches of our species, connected by ancestry, but shaped by different suns. But beyond biology, our minds would also evolve. Living on perfect worlds may reshape human philosophy. We may begin to value stability over innovation, harmony over conquest, cooperation over competition. These worlds might teach us humility, reminding us that life thrives in many forms, on many worlds, under many conditions. But they may also teach us ambition. Seeing worlds that flourish effortlessly would highlight Earth's fragility. We would recognize the urgency of protecting our home. Environmental stewardship might become humanity's defining legacy. And as we learn from these perfect worlds, we may learn how to heal our own, because the greatest gift a perfect world can offer is not colonization, it is inspiration. The discovery of such worlds would transform human culture. Children on Earth would grow up knowing that paradise is not mythical, but real, shining under distant suns. Philosophers would debate the meaning of life in a universe abundant with biological potential. Scientists would launch missions designed to explore these worlds with cutting-edge instruments, probing their atmospheres, analyzing their biosignatures, mapping their surfaces, and someday sending robotic explorers to land on their soil. And eventually, inevitably, humans would stand upon them. When that day comes, it will mark the beginning of a new epoch, the moment humanity becomes a species not bound to one world, but shaped by many. A species whose story is written not on a single planet, but across the galaxy. Perfect planets will not replace Earth. They will expand it, turning our home into the first chapter of a greater cosmic identity. Because if perfect worlds exist, then humanity's destiny is larger, richer, and more beautiful than we ever imagined. If humanity ever discovers planets that rival Earth in perfection, worlds whose landscapes, climates, and ecosystems reveal an elegance shaped across billions of years, then we enter one of the most profound and challenging dimensions of such a discovery. how perfection reshapes the trajectory of civilization itself. Because perfect Earth-like planets are not simply environments, they are opportunities, catalysts, mirrors, and sometimes warnings. They hold answers to questions we have only begun to ask about evolution, technology, culture, and humanity's place in the cosmic order. And the more perfect these worlds appear, the more deeply they confront us with truths about ourselves. Imagine a perfect exoplanet discovered through atmospheric spectroscopy, its light filtered through the lens of an advanced space telescope. Scientists detect oxygen, methane, and other gases that should not coexist unless constantly replenished by biology. The planet's spectral signature glows with hints of dense forests, vast oceans, and biological activity far more robust than anything on Earth. Its surface temperature remains stable, its seasons mild, its star calm and long-lived. Such a detection would send shockwaves through science and society. It would be humanity's first evidence that Earth-like conditions are not unique, but part of a broader pattern woven into the chemistry of the universe. Now imagine the moment we create the first digital elevation model of that world. A rough outline of continents and oceans calculated from subtle gravitational variations and light curves. We see coastlines shaped with mathematical precision, mountain ranges that rise gently instead of violently, carved by slow tectonic forces rather than catastrophic upheaval, river systems that flow in elegant patterns, distributing nutrients across continents with breathtaking efficiency. Every detail hints that this world is not merely habitable, it is optimized for life. This raises a haunting question. Did nature create this perfection, or did something else? For most scientists, the answer would lie firmly in natural processes, but others might whisper about ancient civilizations, planetary engineering, or cosmic-scale evolution. Even if speculation remains unproven, the possibility itself would ignite human imagination. Literature, film, philosophy, and theology would grapple with the implications of a universe in which perfection arises more than once. But let us assume the perfection is natural. What does such a world tell us about the forces that shape life? Perhaps Earth is not the upper limit of habitability, but merely one point along a spectrum. A perfect world might teach us how diverse planetary systems can develop stability far beyond Earth's capabilities. For example, its star may be a K-type dwarf, burning steadily for tens of billions of years. Such stars provide climates far more stable than our Sun could ever guarantee. Their planets may enjoy extended habitable windows that allow evolution to unfold at a leisurely, unbroken pace. Imagine what life could become under such conditions. On Earth, only a handful of species manage to develop intelligence. But on a perfect world, intelligence might not be a rare evolutionary outcome. It might be common. Multiple intelligent species could coexist across land, ocean, and air. Aerial species might develop advanced navigation using electromagnetic fields. Aquatic species might evolve complex language through hydrodynamic pulses. Land species might develop symbolic communication embedded in color-changing skin or pheromonal patterns. A perfect world might hold civilizations layered on top of one another, each occupying its own niche, none dominating completely. But even if intelligent species exist, communication may be nearly impossible. They might not use radio waves. They may not build machines. Their awareness might be internal, introspective, or collective. Their societies could be deeply integrated with natural cycles rather than separate from them. They may have no concept of technology as humans define it. Instead, they might shape their environment through biological means, altering genes, modifying ecosystems, or influencing species through subtle biochemical cues. To humans observing from afar, these civilizations might appear invisible. Their industrial signatures may be too faint to detect. Their cities may blend seamlessly into the natural environment. Their communication signals may lie outside electromagnetic channels. We may mistake their world for a pristine wilderness, when in truth it is a highly advanced biosphere operating on principles beyond human comprehension. Now imagine a scenario where we send robotic probes to explore this perfect world. Our machines enter the atmosphere, passing through layers of clouds enriched with complex organic aerosols. They descend toward lush landscapes teeming with life. Every plant, every tree, every microbe reveals evolutionary patterns distinct from Earth's. DNA may not exist, Proteins may be constructed differently. Metabolism may rely on chemical pathways unfamiliar to our biochemistry. Life, while abundant, may be fundamentally alien. This introduces a monumental challenge. How do we study life that shares no common ancestry with us? Earth-based tools rely on the assumption that life uses DNA, RNA, amino acids, or similar organic structures. But on a perfect world, evolution may have taken entirely different routes. There may be no analogues to our proteins, lipids, or enzymes. Our biosensors might not recognize alien biochemistry. Our probes may struggle to categorize organisms whose molecular foundations lie beyond terrestrial frameworks. To bridge this gap, humanity would need a revolution in exobiology, new instruments capable of detecting life by patterns, not molecules. We would look for thermodynamic complexity, metabolic energy gradients, ecological cycles, and signatures of self-organization. Life would no longer be defined by chemistry alone, but by behavior, structure, and systems-level patterns. But the greatest challenge may come not from biology, but from ethics. If a perfect world exists with complex but fragile ecosystems, even the presence of a robotic probe could cause contamination. Microbes from Earth might infiltrate local environments. Chemical residues from spacecraft could alter atmospheric chemistry. Even the act of landing might disrupt evolution on microscopic scales. This raises a question humanity has never faced. Does exploration justify the risk of damaging another living world? The more perfect the planet, the greater the moral responsibility. Some argue such worlds should remain untouched, cosmic sanctuaries whose beauty and harmony must be preserved. Others argue that knowledge is worth the risk. And still others argue that humanity must learn to explore without disturbing, a technological challenge that may define the next century of space research. But the story grows even more complex if such a world contains intelligent species. How would we approach them? Would they perceive us as threats, curiosities, or myths? Would we even recognize their intelligence? On Earth, we often fail to recognize intelligence in our own oceans. A perfect world may contain entire societies invisible to our preconceptions. Imagine arriving near one of their settlements. There are no buildings, no roads, no fires, but the forest behaves strangely. Trees sway in patterns that reflect deliberate communication. Underground networks exchange chemical information. Creatures move in coordinated patterns, synchronized like neurons firing in a brain. Slowly, we realize that intelligence may not be located in individuals. It may be distributed across entire ecosystems. The planet itself could be a thinking entity, its intelligence manifested through biological networks spanning continents. If this were true, humanity would be forced to reconsider its definition of consciousness. We might stand on the surface of a living world that thinks, remembers, and responds. Every footstep could be a conversation. Every breeze could be a signal. Every shift in temperature could be an act of planetary cognition. But perhaps the most startling possibility is that a perfect world contains no life at all. A world that appears habitable, rich with oceans and continents, but utterly barren. A planet that had every opportunity for life to flourish, but did not. Its perfection becomes a mystery. Why did life not arise? Were conditions too stable, preventing the chemical disequilibrium needed for life's spark? Did something suppress biogenesis? Was life wiped out in its earlier stages? Or does life require some feature unique to Earth? A lifeless perfect world would be as haunting as a living one. It would tell us that habitability does not guarantee life, that even paradise can be empty. And such a world might become the ultimate canvas for humanity's dreams. An untouched planet where we could build a second Earth, a chance to write a new chapter of human civilization. Colonizing such a world would redefine human identity. Entire generations would grow up under alien skies. Cultures would evolve around local conditions. Holidays might develop around the rhythms of a different star. Architecture would adapt to different gravity, weather patterns, and resources. Language would evolve new words for phenomena unseen on Earth. Children would study constellations unrecognizable to their Earthborn ancestors. Humanity would become a multi-world species, not just physically, but culturally, psychologically, and perhaps biologically. Over centuries, humans on different worlds might diverge into distinct lineages, each adapted to its environment. Some might have denser bones on high-gravity worlds. Others might develop enhanced night vision under red dwarf stars. Evolution might resume its work, sculpting humanity into new forms shaped by the perfection of alien worlds. And yet, no matter how many perfect planets we discover, Earth will remain our origin story. A perfect world does not replace Earth. It contextualizes it. It reminds us that Earth is not a singular miracle, but part of a cosmic tapestry of possibilities. It teaches us humility and wonder. It expands our vision of what life can be and what humanity can become. In the end, the discovery of perfect worlds is not just a scientific triumph. It is a philosophical awakening, a reminder that the universe is not merely a place we observe, but a place we belong, a place filled with destinations, mysteries, futures, and perhaps neighbors, a place where humanity's journey has only just begun. If humanity ultimately discovers planets so astonishingly balanced, so biologically rich, and so cosmically rare that they rival Earth's own harmony, then we are brought to the final, and perhaps most transformative, dimension of this journey. What happens after the discovery? What happens when the idea of perfection shifts from imagination to observation, from telescopic dream to measurable reality? Because the discovery of perfect Earth-like worlds would not simply expand our scientific catalogue, it would redefine our future, redirect our ambitions, and alter the trajectory of our civilization for millennia to come. Imagine the moment when, after decades of searching, a space telescope transmits data showing the atmospheric signature of an exoplanet that checks every box for habitability: oxygen at stable concentrations, methane at trace levels, signs of photosynthesis, liquid water, moderate temperatures, and an equilibrium hinting at a thriving biosphere. The scientific community erupts. News spreads instantly. Humanity, for the first time, knows that Earth has a twin, or perhaps something even better. The psychological impact is immediate. The cultural impact is indescribable. We would no longer look at the night sky as a field of stars, but as a map of possibilities. Each point of light a potential home, a potential sanctuary, a potential mirror. Such a discovery would spark a wave of global cooperation, unrivaled in human history. Space agencies would align priorities. Nations would set aside differences to fund missions capable of observing the world in greater detail. Universities would expand exoplanet research programs. Private companies would invest in propulsion systems once considered impossible. Humanity, for the first time, would share a collective goal beyond Earth, understanding and eventually reaching this perfect world. But understanding perfection requires more than atmospheric analysis. Scientists would begin constructing detailed models of the planet's geology, climate cycles, ocean chemistry, and potential biosignatures. Simulations would attempt to reconstruct the planet's evolutionary history. We would ask, how old is its biosphere? How stable is its climate? How long will it remain habitable? And most importantly, does life there resemble anything we know? The next step would be determining whether the world contains complex organisms or even intelligent life. High-resolution spectroscopy might reveal fluctuations in atmospheric gases indicative of massive blooms or migrations. Light curves could hint at seasonal patterns, glacial changes, or shifting vegetation. In some cases, we might detect artificial structures, geometric patterns, or spectral signatures inconsistent with natural landscapes. But even if the world hosts only microbes, the discovery would still be monumental. A second genesis, independent life, would confirm that biology is not an Earth-specific accident, but a universal phenomenon. Yet perfection also brings risk. A perfect world might be fragile, balanced delicately on chemical and ecological interdependencies that are easily disrupted. If humanity visits such a world, we risk contamination, introducing Earth microbes that could devastate alien ecosystems. Some scientists would argue that such worlds must remain untouched, protected as cosmic heritage sites. Others would insist that exploring them is essential for understanding the nature of life, and still others would advocate colonization, believing that humanity must expand beyond Earth to survive long-term. These opposing viewpoints would shape decades of debate. Ethics committees, international treaties, planetary protection protocols, all would evolve to address the challenge of interacting with a world that may represent nature's highest achievement. But humanity's curiosity is relentless. Eventually, We would design missions to send probes. The first would be remote, equipped with sterilization systems, advanced sensors, and AI-driven decision-making. These probes might orbit the planet, mapping its terrain in exquisite detail. They might deploy atmospheric balloons to drift on alien winds, sampling airborne compounds. They might release nanoscopic autonomous scouts capable of studying environmental chemistry without disturbing local life. The data returned would ignite a second revolution. With high-resolution surface imaging, we might see forests stretching for hundreds of kilometers, oceans shimmering with plankton-like organisms, deserts minimal or non-existent, climates temperate and stable. Every detail would point to a world optimized for life in ways Earth can only approximate. And then, one day, a probe might send back something that changes everything: a structure, a pattern, a signal, a sign. Not necessarily a city, not necessarily technology, but something unmistakably intentional. A repeating geometric layout in forest growth, a symmetrical formation of bioluminescent patterns in oceanic life, or perhaps a spectral signature from atmospheric chemicals produced only by industrial processes. Humanity would hold its breath. If intelligent life exists on this perfect world, its nature would shape the next era of human history. Are they advanced? Are they peaceful? Are they aware of us? Are they waiting? Or are they so different from us that communication is impossible? Imagine the first attempts at contact. We transmit mathematical sequences, universal constants, simple rhythmic pulses, signals designed to indicate intelligence without confusion. Days pass, then weeks, years. Perhaps we receive no response, or perhaps we receive something unexpected, a faint modulation in the planet's reflected light, a deliberate variation in atmospheric gas composition, or even a burst of organized electromagnetic energy. If contact is made, humanity would undergo a transformation unlike anything in history. Cultures would shift, economies would reorient, governments would reorganize, religions would reinterpret their cosmologies. Every field of human thought, from psychology to philosophy to ethics, would evolve to accommodate the reality of another intelligent species. But what if the civilization is gone? What if the planet is perfect, but its inhabitants vanished long ago? We might find ruins overgrown with alien vegetation, remnants of machines encrusted with mineral deposits, or cities submerged beneath oceans. Such a discovery would provoke profound questions. Did they destroy themselves? Did they transcend physical existence? Did they leave? Or did perfection itself make them vulnerable to a catastrophe they could not survive? Their extinction would not merely be tragedy, it would be a warning. A perfect world does not guarantee eternal stability. Even the most advanced civilizations may fall, and in their absence, humanity would confront the truth. Perfection cannot be taken for granted. It must be maintained, protected, and cherished. Earth, too, requires that care. Now imagine a future where humanity does travel to these worlds, first through robotic probes, then through cryogenic missions, then perhaps through propulsion technologies not yet invented. Colonists would step onto soil untouched by human feet. They would breathe alien air, swim in alien seas, study alien life, and build futures under alien skies. Over generations, they would become indigenous to these new worlds, evolving physically and culturally in response to local conditions. Humanity, once confined to a single planet, would diversify across the galaxy. Each perfect world would become a seed for a new branch of civilization. Some branches might remain peaceful and scientific. Others might grow ambitious, territorial, or even divergent from Earth-based values. Over millennia, humanity might become not one species, but many, each shaped by its homeworld. This cosmic diaspora would bring not only opportunity, but responsibility. Perfect worlds must be protected. Their ecosystems must not be exploited. Their histories must be preserved. Their inhabitants, if they exist, must be respected. Humanity's expansion must balance ambition with stewardship. And so, the discovery of perfect exoplanets becomes more than a scientific milestone. It becomes a test of our maturity as a species, a moment when we decide whether to embrace a future of cooperation, exploration, and respect, or repeat the mistakes of our past. In the grandest vision, humanity does not conquer perfect worlds. We learn from them. They become teachers, guides, mirrors that show us what is possible when nature has time, stability, and freedom to experiment. They inspire us to restore Earth, to cherish its diversity, to stabilize its climate, and to understand our planet not as fragile or flawed, but as one beautiful variation among many cosmic masterpieces. Because in the end, discovering worlds that rival Earth does not diminish our home. It elevates it. It places Earth within a family of extraordinary planets. It affirms that life is not an accident. It is a pattern, a cosmic rhythm waiting to be recognized across the galaxy. And it marks the beginning of humanity's true journey, not as inhabitants of one world, but as citizens of the universe. Not as observers, but as participants in a cosmic story billions of years in the making. Not as isolated beings, but as a species destined to walk among the stars. The discovery of perfect worlds is not an ending. It is the moment everything begins. Thank you for watching. If you enjoyed this video, leave a like and share your thoughts in the comments. Send it to someone who you think would enjoy this topic too. And of course, subscribe and turn on the notification bell so you don't miss the next videos. See you next time.